All right, on page 732 today, we're going to talk about and work with tangents. A tangent is a line that intersects a circle in exactly one point. Called the point of tangency. A tangent is a line that intersects a circle in exactly one point, and that point is called the point of tangency. A common tangent intersects two or more circles in the same plane. All right, so today you're going to be drawing some lines of tangency and some common tangents, and then you're going to use a rule or a theorem related to tangents to circles to find out if a tangent is perpendicular to a radius. So first thing we're going to do is look at example 1. It says to copy each figure and draw the common tangents. So try to draw something that looks like this. And then we've got a smaller circle that overlaps it. And you're asked to draw the common tangents. If no common tangent exists, state no common tangent. So before we draw these common tangents, let's just draw one circle. And then if you don't have a straight edge, sometimes this is hard, but all we're trying to do is draw a line that just touches the circle. And where the line touches the circle is our point of tangency. All right, so if we label this point A and line L, we could say that line L is perpendicular to circle C at point A. Line L is tangent to circle C at point A. So if we're drawing common tangents, in this case we have two circles. So we're trying to draw a line here. I'm going to do this first line across the top if you can see the cursor. And I'm going to try to hit these 2 points. So like I said, with a straight edge, it's much easier. So something like this. Line M is a common tangent to these two circles. All right, if we try to do the same thing on the bottom of the circle, we're just going to take a line and we're going to draw it going through these 2 points. All right, so here's line N. So these 2 circles have 2 common tangents. Everybody okay with that? When the circles don't overlap and they're separated, if we take, again, a circle here on the left, and then a smaller one on the right, and now they're not overlapping or touching. And now we're going to draw some tangents. All right, again, we could go right across the top of both circles. Here's a common tangent. All right, L. We could do the same thing across the bottom, like we did in the overlapping circles. And now, since the circles are separated and they're not overlapping, we can do diagonals, okay? If you can imagine a tangent that's a diagonal going through these 2 circles. So maybe we got something that looks like this. Line N. And then if we can get a diagonal going that direction, we can get one going the opposite direction as well. So we'll call that line P. All right, so that's the way to draw common tangents. Basically, when the circles are separated, I'm pretty much thinking you're always going to have 4. When the circles are intersecting like that, you're probably going to just have 2. Maybe an example. If you've got a circle and then it's got another circle inside of it, there's no way to draw a common tangent, is there? Because anywhere we were to draw a tangent on the big circle, since it can only hit the circle in one place, it's not going to hit the little circle inside, is it? All right. And anywhere that we drew a tangent on the little circle inside, let's say we drew it up here, well, it's not going to be tangent to the circle on the outside, is it? Because it's going to hit it in 2 places. All right, so when you've got a circle inside a circle or a circle outside of a circle or concentric circles, you're not going to have any common tangents, okay? All right, so look at the top of page 733. We got theorem 1010 up there. And theorem 1010 says, in a plane, a line is tangent to a circle if it is perpendicular to a radius. drawn to the point of tangency. A line is tangent to a circle if it is perpendicular to a radius drawn to the line of tangency. So here's what a picture looks like. If we've got a circle, and now in that circle, we draw in a radius. So if I label this circle A and a point of tangency, point B, and I connect them with a segment, that's a radius. Now let me take a tangent here. Because a tangent can also just be a segment. So if I put point C right here. In a plane, a line is tangent to a circle if it is perpendicular to a radius. So if BC is perpendicular to AB, then by rule, BC is a tangent. If it's not perpendicular to the radius, then it's not considered a tangent. It may look like one, but if the tangent doesn't intersect the radius at 90 degrees, then it's not a tangent. Okay? Or I'm sorry, I should say, if a line or segment doesn't intersect the radius at 90 degrees, then it's not a tangent. So we're going to use the Pythagorean theorem to determine if segments are tangents. So look at example 2. Example 2 says, let me redraw this. Let's just add this 90-degree angle right here. And let's say BC, let's say if BC is perpendicular to AB, then it is a tangent. If BC is perpendicular to AB, then it is a tangent. So now we can look at example 2. And in example 2, we're told that JL is a radius of circle J. Determine whether KL is tangent to circle J. Justify your answer. So here's the picture we've got. Here's circle J. Here's point L on the circle. And then we got point K out here. Determine whether KL is tangent to circle J. All right, bad drawing on my part, but we get the idea, right? So what we're going to do here is we're going to turn this into a triangle. We're going to add these dimensions. K to L is 15. Now, where this 9 is, this 9 goes from point K to the edge of the circle. It doesn't go all the way to the inside or to the middle of the circle. So L to J is 8. When you're doing these problems this week and this number is out here, it's only from here to here is the 9. What we're going to do now is we're going to take 8 squared plus 15 squared. We're going to see if it equals the hypotenuse squared of this right triangle that we just formed. All right? because we're trying to determine if this is a right triangle. Because if this triangle that we just drew is a right triangle, then this angle L down here is 90 degrees. And if angle L is 90 degrees, then KL is tangent to circle J. That's the process. So we got to take this 8 that goes from J to L and add it up here as well, because it also goes from J to the edge of the circle. So now we're going to take 15 squared plus 8 squared, and we're going to see if it equals 9 plus 8 squared. Okay, so in your calculator, you can do the left side. You can do both sides in your calculator. So do 15x squared plus 8x squared, and I get 289. And the open box means I'm comparing it, okay? I'm comparing it to the 9 plus 8. So do 9 plus 8 equals, and hit x squared, and I get 289. So if the two legs squared, or the sum of the two legs squared, is equal to the hypotenuse squared, these two are equal. What that means is that this angle is 90. And if that angle is 90, then KL is tangent to circle J. We're taking the triangle that we either have to form on our own or that's given to us. We're determining whether it's a right triangle. If it's a right triangle, then the line is a tangent to the circle. If it's not a right triangle, then the line is not a tangent to the circle. So let's take a look at the circle right below that. And now we've got this picture going on. We've got G to F. Got point H up here at the top. HG is 8. From H to the edge of the circle is 12. G to F, which is the radius, is 6. And F to the edge of the circle is also 6. Determine whether GH is tangent to circle F. We're trying to find out if the radius is perpendicular to GH. So we're going to take 8 squared plus 6 squared, and we're going to compare it to 12 plus 6 squared. So on the left-hand side, we got 8 squared plus 6 squared, which is 100. And we're comparing that to 12 plus 6 squared, which is 324. All right, and since 100 is not equal to 324, then we say GL GH is not tangent to circle F. The sum of the squares of the legs is not equal to the hypotenuse squared. So this angle right down here is not 90 degrees. And if that angle's not 90 degrees, then GH is not a tangent. All right, so any questions on tangents, common tangents, determining if a tangent, if a segment or a line is actually tangent to a circle? All right, then your practice for today is going to be start on page 736. I'm sorry, 735. On 735, do 1 through 3. And then over on the next page, 9 through 16. Please make sure you're doing all the problems and that you're checking the odds in the back of the book. On a short week again this week, so study guide will be on Wednesday, quiz will be on Thursday. You guys don't have any school this Friday.